All right, we're gonna go ahead and finish this up. Couple points I want to make before we move on from the voltage is Dave mentioned motors and everything else failing, but circuit boards, VFDs, if you do commercial stuff, you dealt with VFDs failures. ECM motors, all those electronics don't like power issues. And some of the things with this voltage imbalance he was talking about, when we lose circuit boards, especially, like I said, VFDs or circuit boards or mini splits, 98% of the time that was power that did it. And the more we're dealing with them, the more we're seeing these power issues. So, if you're going through losing a circuit board on a mini split, you're losing VFDs on rooftop units. That current imbalance is a big one that a lot of us never really check for too much. And sometimes you'll have a 25% current imbalance. And it's really strange how it works. You would think it was the motor doing it, but it's actually happening before the motor. So that's just a big thing. So if you're losing motors, you're losing especially control boards or VFDs, we want to look at about putting protection on there as far as phase monitors on 3-phase. We have single phase voltage monitors. So it's definitely worth looking at that. And it's just going to get worse because we're going to put more electronics on more things. Before you know it, we're going to have variable speed compressors on rooftop units. It's coming. It's coming. So those are other things that more so that get tore up by the power issues. Okay, so I'm not. Let's see here. You got through the. Well, you were at the capacitors. Okay. We got through all this. So again, these tests here, especially if you're frying stuff like that, it's definitely worth something to check through. So capacitors, we want to look at these. We still use a lot of capacitors. We've bypassed a lot of them now because ECM motors don't use them. First of all, ECM motors are all 3-phase motors. ECM compressors, a compressor in a mini split is a 3-phase motor. 3-phase compressors are pretty easy to check. Check resistance. They should all be even. And then check the ground. You got anything at all to ground, they're dead. Okay. With your ohm meter, you got like 6 settings on there. Always start at the lowest setting and work your way up. Okay. So start at your lowest. If you've got a 200 ohm, start there. Then you go to your 2K, then go to your 10K until you get a reading. Okay. OL is just it's out of its range, or it's open, but always start at the lowest and work your way up. Okay. So when we're dealing with capacitors, pretty straightforward. The metal ones are run capacitors. The bakelite ones are start capacitors. They do hold a charge. Okay, so be aware of that. When we're dealing with circuit boards, this is actually a little inverter board for a condenser fan motor. These little guys will hold a charge just like those will. These are capacitors, same way. So when you're dealing with this, and we get more into inverter boards, these will hold up to 300 volts for up to 5 minutes. Okay, and you want to make sure you give it a full 5 minutes before you start poking your hands around in there. And if you ever want to see something, you go to the back side of the capacitors and shut the power off, put your voltage there, your voltage meter there, set it to DC and go across those capacitors and watch how long it takes to discharge. DC volts is pretty dangerous, okay, because when it comes out, it grabs a hold of you and it holds on. So Mike and I, like I said, we have a window between our offices, and he was on the phone with somebody with a extreme heat, the 284, and the guy was talking to him on the phone, and he got hit by that 300 volt DC, and you could, and he comes back, it was like silence for probably a good 45 seconds. And he finally, wow, and he did end up in a hospital that night. So just be careful. Okay, the module on an ECM motor has these. Okay, the inverter board on any of the variable speed compressors has these. Okay, all the mini splits have them. So when you shut those down, 5 minutes before you start poking around on those boards. And if you don't got patience, because we're all service people installers, because we don't have patience, right? Because we don't want to sit in school. So put your meter on there and watch. They say wait till they get down below 50 volts before you start poking around on them. Okay, and they will hold it. The new mini splits, the new multi-zone mini splits are going to hold it for almost 10 minutes because they have a new safety valve they have to shut off. Okay. So you might notice when you go to reset something, even it connects, you shut the power off and the connect stays lit up for a little bit. There's capacitors in there and it holds that for a little bit. So it takes time to discharge. So, we want to discharge on start capacitors, that resistor up there, that's what it's for. It's to bleed the voltage off of those. It lengthens the life of the relay. But even the little run capacitors, they hold a charge. Shut the power off, take your screwdriver, short across terminals before you touch them. Okay. We used to in school 100 years ago, used to charge them up and run around a room and zap each other, which is not a bad idea. Or not a good idea. Don't do that. I have it on record over there. I said not to do it. Yeah.
Be careful if you ground them or, short them with your screwdriver. I've never had it happen, but my instructor in school said he's done that and he's had capacitors blow up in his hand before.
Okay. See, and I've never had it either. So yeah, good point. Or like I said, you can just put your DC voltmeter, you can check for voltage and just make sure they're dead. If you ever cut this bleed resistor off of there, because the way to test, nowadays we all have meters that have microfarads on them. And you have to cut that bleed resistor off. So if you have to cut it off to test it, we sell a bleed resistor with spade connectors, put it back on there. Because again, that's just there to bleed it down. So the aluminum one is designed to be in the system all the time. It's full of oil. And it stays in the whole time. The start is only in there momentarily. Okay, so again, there's that bleed resistor. If you happen to cut it off, because we're going to check or to test that, we have to cut the resistor off. Okay, so start capacitors, which normally we add them on. We don't normally have them OEM, but we have aftermarkets we can add on. But when we replace the start capacitors, okay, power them down, make sure they're bled down. Again, most of our meters have microfarads on them, which is that funny looking UF symbol. Most of your meters have it. You just read it across the top. Plus or minus 10% for run. They say 20% for start. Okay, plus or minus 10% of the rating on it. Take the bleed resistor off first. The runs, plus or minus 10%, same thing. This is a dual run, so this is actually two capacitors, one for fan, one for compressor. Now, be careful when you wire these in, because if you miswire these, you can actually make the motor run backwards. So, if you get a motor running backwards, fan motor, make sure you double check that capacitor wiring, because if you get it reversed, you can actually make them run backwards.
Quick question on that.
Yes.
These are labels plus or minus 6. All of them.
Plus or minus 6. Well, see, that's the difference in the brand too, because some of them are tighter than that. That's the way they're rated from the factory. So you might get them plus or minus 10. That's the cheaper ones. But they'll be plus or minus 6. Some of them are plus or minus 5. But that's from the factory, meaning on a run, it's a 7.5. They're telling you right out of the box, plus or minus 6% or 8% or 10.
That's not like.
No, it has nothing to do with replacements. No. No, but that's a good point, because if it says on there that amount that it's allowed to be off, you got to take that into account. Okay. So again, testing capacitors. Most of us have an Annie. None of you have ever probably seen one of those. If your company's been in business any length of time, you probably got one floating around. Discharge them. This is the microfarad symbol. Put it in, and then you just check the microfarads. Okay. Repairs. Okay, so when we get into the system itself, before we move on, is everybody clear on the capacitor? It's pretty straightforward. Like I said, that bleed resistor is there. If you cut it off, the start capacitor, you're just shorting its life, because it's going to arc every time it closes. So, as we go in this new refrigerant, okay, we are still using PUE oil. Now, PUE oil is very hygroscopic. It's like a sponge. It sucks water in like a sponge. You go out in the branch, or if you've ever seen a can of PUE oil, it's a metal can. If you look at a can of mineral oil, it's a plastic jug like antifreeze. The reason for that, because the POE will actually suck the water right through the plastic. And if you've been around long enough, when it first came out, it came in a plastic jug, and the jugs would be so swelled up on it, you couldn't get it to stand up on a shelf. So that's why they switched it to metal cans. So something we want to be careful with POE is that it's dry, okay? We keep it dry, we keep the system dry. It is possible to get POE so wet we can't dry it out. Okay, it'll actually break down to mild acid and alcohol. If you got a system that's been sitting, let's say you get called out and the thing, sometime this winter got something shot and blew a hole in the condenser and you lost all the charge, you might want to do an acid test on that oil. Okay, because if it's been open and exposed to moisture all winter, the vacuum pump won't get it out. Okay, because if there's enough moisture, it'll actually just break the oil down to acid and alcohol. So just be aware of that. Vacuum pump oil. And this sounds like something silly to tell you, but you need to change your vacuum pump oil. All right. And I know most of you work for somebody else. The boss paying for it. No, honestly. The moisture that comes out of that system goes into the oil. Is everybody familiar with that little bleed ballast port on your pump? Do you all know what that's there for? You should leave that open until you're down about 20 inches because all that big gush of moisture that comes out first, that's what that port is for, to allow it to escape the pump without putting it into the oil. So open that ballast port. That keeps the oil dry. If you question how much dry oil improves your pump, take your vacuum pump when you have not changed your oil, put your micron gauge directly on it, turn it on. Change the oil, try it again. Huge difference. Huge difference. So change the vacuum pump oil. Should be every time you use it, or obviously, if you're doing Mrs. Smith's little 2-ton and he's got 15-foot line set and I just changed the oil and I'm going to do another one this afternoon, well, I probably don't need to change that. But if you're doing big systems, dirty systems, wet systems, change the oil. Something we've been seeing on mini splits recently. Mini splits do not have filter dryers on them, right? Filter dryer's main job is to dry. It's to absorb moisture. Mini splits can't have them just by their nature. And recently we've been getting, I've had about 4 of them. Guy sends a picture to me of oil coming out of the mini split and it's green. It almost looks like dye. That's moisture. Okay, this moisture in the system. Those mini splits were never evacuated properly, or they had multiple leaks. And you know how copper turns green when it gets wet? So that POE oil sucked all that moisture in, so somebody didn't do a proper evacuation to start with. You got no filter dryers to take care of it. I've never seen it in a regular system, but now in the last 6 months, I've had 4 mini splits do it. And they were probably 3 or 4 years old. They might have either never dried out properly or had leaks. So again, this is another one of those things we get kind of comfortable with, right? Put a pump on there. All right, this is still a very important part of what we do. Okay. Change your oil first. I talked about the micron earlier. Now, I always said if I started a business, I'd make all my new techs use analog gauges for the first 2 years of the PT chart, because then they understand what they're doing. The one thing I wouldn't do is this, because this gauge here is absolutely worthless for vacuum. So 30 inches between 29 and 30 is that last line there. And I like to show this just because sometimes we the boss tells us to do it. Why do we do it? Well, because this is why we do it. So we need to get water to boil in this room right now, right? If we have moisture in the system, we need to get it to boil to suck it out. So it's 70 and 72 in this room. I got to get to 29.2 inch vacuum. On that gauge there, can you really tell you're at 29.2? No, because right now it's slightly out of calibration. It's going to read off anyways. That gauge is absolutely useless for vacuum. Now, when we started, we didn't have fancy micron gauges, so we used to listen to the pumps. That's what they always told us. Wait till the pump gets quiet, right? Okay, not a great idea. But we had mineral oil, which was very forgiving. POE is not. So, the micron gauge. And again, everything we're trying to get to in a micron gauge is between about 29.3 and say about 29.7. So all within that last little line. In microns, 29 inches is 25,000 microns, 25,400. So that's why it's so much more accurate. I know they sell gauges with the micron gauge built into the gauge. Don't really care what the microns is at the gauge manifold. I care what the microns are at the unit. So ideally, your micron gauge should be at the unit itself. So anybody got that Navac pump with the micron gauge built into it? Really pretty cool. We do have one, and you might have, 1,800 microns at the system yet, and that pump is reading 200. So because what it's reading on the pump, I might have 200 at the pump, but not necessarily in the system. So this is a really important thing we do. The advent of all these digital gauges we have, this really helps us do our job better. And the micron gauge tells us what's going on in the system. If you're going to reuse a line set, and I said before, check the size. That POE oil that's stuck in that line might have moisture in it. It might have crap in it. So I would definitely suggest flushing that line set if you're going to reuse it. Okay. One of the methods I've been kind of sold on, everybody see that gun we sell, shoots some little rubber plugs? Not by itself. You pour some flush, and then you use that rubber plug and blow it through a couple times. Okay, and that seems, the combination of the two is funny because the company makes the plugs, say ours are the greatest, and the flush guys say, oh, that sucked. Now, then they say the flush no good. Actually, I've seen it really works good with both. Not like a whole bottle of flush. You just pour some in there and then shoot them pigs, they call it pigs, back and forth. But clean that line set out. Okay. Obviously, not doing things correctly causes us lots of problems. That green, it's real obvious because we have no filter dryers that you see it. And I got several of those pictures now where that's happening. So proper evacuation, change the vacuum pump oil first. Run nitrogen when we braze. Okay, we should be running nitrogen when we braze, just because all that carbon shit that we get built up, and you talk about TXV sticking, right there alone, that carbon crap in there can get in the TXV and cause the thing to stick. Water in the TXV can get the thing to stick. Rust. Moisture in that thing is going to cause rust. It can cause ice, which causes restrictions, which again can cause a TXV to act funky. TXV might look fine, and all of a sudden after it runs for a while, it's not working right again because you just got some ice created in the seat of that TXV. So Copeland, which is claims that no compressor failure is their fault. Well, I'll disagree with that because of the K7 series that we went through about 2 years ago was their fault. And that rust inhibitor that caused the TXV problem, that was their fault, but it's not ever their fault. So anyways, when you look at their report, more than 60% of compressor failures is field issues. We got moisture in there. Moisture destroys the oil. If we destroy the oil, we have no lubrication. Okay, and once POE oil is wet, you cannot dry it out. There's just no way to do it in the field. So warranty compressors, I just like to add, before you bring them back, you should all know this, you have to seal the old compressors before they come back. Okay, our branches should not be taking them back if you don't, but crush the stubs, braze them shut before you bring it back. Okay. Like I was saying earlier, this is the 5-stage compressor. This has now been changed to a variable speed. This is now the 290. So the 288, which was a 5-speed, is now full variable speed. Okay, but this has an inverter in it, just like a mini split. Okay, it has those capacitors. It holds all that voltage. Okay, Dave talked about TXVs. These have EXVs, electronic expansion valves. They work exactly the same. The TXV has a sensing bulb on it, right? And it controls and maintains superheat. This has a thermistor on it. Okay, it's not connected directly here, but on the control board somewhere. It's doing the same thing. It's maintaining superheat. This is a stepper motor in here. So this is actually a motor. So like any other motor, you check it with an ohm meter to see if it's good. You can pull this off here, and I think Dave mentioned it, and you can actually look inside here. I'm going to pass it around for a second, and you'll see there's a lineup of magnets in there. And what happens is these things is they get full of moisture because they sweat, and they rust. So one of your maintenance things when you're dealing with anything with electronic expansion valves, mini splits, 288s, 194s, or 189s, take the expansion valve motor off. Take your emery cloth to this and clean this up. You can still see some of the rust. And then get your little wire brush, and you're not going to hurt it, and clean that up. Okay, because that's what happens to these. So there's physically a needle inside this valve, and through the stainless, this motor is actually magnetically getting a hold of that stem, and it's physically screwing it in and out. So you get a bunch of rust in there, and it's going to stop from working. So that should be a maintenance item. And again, ohming it out. Everyone's a little different. You grab the service manual, it'll tell you from 1 to 3 should be this many ohms. Consistency. It's a motor, so all the windings should be consistent when you ohm it out. Okay. Okay, the heat pump version of the same thing. Again, electronic expansion valve on the heating side. What do we have on the cooling side? It's a TXV, right? It's still a coil. You have a V coil, an N coil with the TXV on the inside. Okay, the extreme, this is the full variable. That's the great big doghouse sitting over there. Okay. Again, this is the electronic expansion valve on the outside. There's actually 2 on this one. But there's an inverter board in here. It holds the charge. Okay, so we want to be careful of that. Okay. Software on the connects, and not all of you do the connects. Okay, the connects controller, the wall controller, the software does need to be updated on those from time to time. If it's online, it should do it automatically. Okay, when you install one, has anybody had one installed one where it didn't recognize the furnace recently? Okay, so one of the things you should do first when you're installing one of these animals with the connects, because the connects, as they send them to us, it sits in our warehouse. It might be in our warehouse for 8 months. And then there's some update for something. So get the thing powered up and get it online. Okay, so you're going to do an install. You're going to put the connects in. One of the first things we want to do is get the connects powered up. You can do this at your shop too. Okay, and then powered up, get it connected to the internet. And what'll happen is that then it'll sit out there and it's going to look for updates and it will update itself. Okay. Because currently, sometimes on the 987s, the full variable speed furnaces, you go to set the thing up and it'll say, can't see the furnace. I can't find the furnace. And it's just simply an update. So we just got to get the thing powered up, connected to the internet, and then it'll come up and say, do you want to run in demo mode? Yes. And then just let it sit there. And it takes about an hour, for a half hour, 45 minutes or so, and it'll pop up on the screen and say, update available, would you like to download? Hit yes, you're done. So you can go about doing your other stuff while that's happening. Okay, so just kind of make it a habit of when you're doing connects, get it powered up as soon as you can, even if, you just hook up C&D, get 24 volts to it, get on the wall, get it online, and so if there's any updates, by the time you go to start the system up, the updates have already happened. Okay. Long line applications. There's something called a long line guide. Now, again, now we have the Service Tech app. It's really easy to find the thing. So if you're going over 50 feet, right? You look in the book says I need 5/8, 3/8 line set. You start to going over 50 feet, you want to go into the long line guide and see what you might have to do. Because it may have you upside the suction line, or it might just tell you I'm going to lose 1% capacity if I do this. Okay, is that okay? That might be okay. So, again, if you're going long line lengths, we want to get the long line guide and see if I need to upsize anything. Mini splits. The line set length is the line set size is the line set size. There are no exceptions. So that head has 1/4 3/8 in it. You are running 1/4 3/8. And if you're replacing another head that was 1/4 half, you're changing the line set. There's no exceptions. Mini splits are very critically charged. Line set has to match the indoor head size. These here, if I go long, you might find out in long line guide I lose 1% capacity. Okay, so I can live with that. Okay, so there's some exceptions to this. These, as we talk about the condenser unit being pre-charged for 15 feet of line set, you're pretty much used to that. It's not always the case anymore. Sometimes they can't hold that much because they go to the new coils, so they might not be able to hold a whole charge. So pay attention to your installation instructions. When you first, you'll get used to it, but when you first get it, it'll tell you factory charge, required charge. So it might tell you right off the bat you need to add this much. Well, what happens is you install it, you got 15-foot line set, and you figure line set, your charge should be good. Well, it's not. So the newer units, the 454B units, you want to check that because a lot of them can no longer hold enough charge for 15 feet. So if you start out thinking it was low from the factory, then where it was actually the system just can't hold it all from the factory. Okay. Heat pump sequence of operation. And this is talking about the extremes, the variable speed stuff. Okay, for a call for cooling, the expansion valve on the heat pump is going to run wide open. Well, remember there's two valves, right? One on the outside, one on the inside. So if we're dealing with that electronic expansion valve, that's in the condenser unit. So where Dave showed you that orifice, there's an EXV there instead. So if we're going to go into cooling, we don't need that valve, right? So it's going to drive the valve wide open. Okay. Compressor RPM and fan motor request from the wall control is going to tell it what to do. Compressor is going to ramp up in stages. Again, on the 288 or the 189, it'll ramp up. It's 5 steps. 284, it's going to ramp up slowly. All right. It's going to level itself out. The ALC control board commands inverter to begin the cycle. It's going to adjust the RPM as required. Inverter monitors compressor speed and outdoor fan operation through the whole run. When we're ready to shut down, the equalizer valve, you notice there's a valve sitting on the top. It equalizes the pressure when it shuts down to allow the system to equalize out. EXV in the outdoor unit closes completely. Now, what's this going to mean during evacuation? We have to open that valve. Okay, so we got to know that this is what it does because, okay, you come to this unit, it's cooling, you need to pull the charge out of the thing, right? You got to go into the connects control and you have to drive the valve open. Okay, there's a service mode there to drive it open. So we got to remember if we're dealing with a variable speed, we got to drive that valve open. Okay, because that's at that liquid line. Brand new, it doesn't matter, right? Because the unit's pre-charged, we're not getting into it. So if we don't, again, we're not going to get a proper evacuation. All right. On the call for heat, open EXV, a preset amount, so it'll probably go to 50%. The EXV in the condenser unit, because now remember the flow, the liquid line is now not the liquid line, it's the saturated line, because we're going to meet it first, and then up the liquid line back to the condenser, back to the indoor coil. Or I mean the other way around, it's going to come to the condenser unit through the liquid line. It's going to meter through the expansion valve, go through the outdoor coil, which is now the evaporator, and then go back to the compressor. Okay, compressor RPMs and outdoor fan motor are going to modulate accordingly. The compressor is going to gently ramp up to stage 2, which is, again, on the 2-speed. On the variable speed, it'll slowly ramp up. It'll adjust from there. The ALC is going to continue to monitor things. And then once we're ready to shut down, that equalizer valve will open again. It allows the system to equalize out. The system all shuts down. Okay. During this process, what is the TXV doing? It's bypassing, right? Remember, the flow is going backwards, so the TXV in the coil is bypassing. Now, one of the things when Dave was talking about airflow, when you're dealing with heat pumps, and again, I know in Michigan, 10, 15 years ago, we didn't put many heat pumps in, right? They didn't work. They do now. So don't forget when you're dealing with your indoor airflow on the heating stage, that's your condenser fan. So it's just as important when you're in your heat pumps running, because that is your condenser fan. And it gets kind of weird if you haven't done too many heat pumps and you're going off on high head pressure in heating and you're out checking your condenser fan, your condenser coil. Wait a minute here. Might be a dirty air filter. It's still sometimes hard to wrap your brain. It's like, wait a minute. Well, no, that's not the evaporator. Now that's the condenser. So airflow is a big thing on the heating side when we're running a heat pump as well. Okay. So as far as maintenance, checking all connections, inspecting contactor to make sure it's clean. Obviously wash the condenser, change the air filters, clean the traps, the condensate from the furnace as well as from the coils, change filters, check for normal temperature split. So this is in the heating. This is something we can simply do on a normal startup to check for my temp rise. Okay. A couple other things. Like I said, when we're dealing with a variable speed piece of equipment, that motor I just passed around, pull those motors off, clean them out. Okay, those will get dirty and I'll see them so full of crud and they won't let the EXV open up. Okay. Like I said, when you're dealing with the variables again, be careful because of that DC volts. Now, the 288, 189, 284, the extreme stuff right now, it's really pretty easy. As you'll see when you open it up, there's a positive and a negative terminal up at the top. There's about 300 volts DC on there. So when you power it down, you can actually just monitor that to make sure. Wait till it gets below 50 before you stick your fingers in there. Okay. Any questions on anything? No, I don't have lottery numbers.
Remind me how we charge the 454?
Liquid.
We have to recharge?
Oh, yes. Can we recharge? Good question. Yes, we can. So, for those who never dealt with, who never lived life without 410, predominantly those of you with no gray hair. When 410 first come out, 410 is a blend. Any refrigerant begins with a number 4 is a blend. And it is called a zeotrope. And like Dave was mentioned a little bit, it's 2 or 3 different refrigerants mixed together to make one new refrigerant. So what happens though is each refrigerant maintains its own boiling point. Okay, so maybe this refrigerant boils at minus 40, this one boils at minus 60. So what happens is if you have a leak, the one with the lower boiling point is going to boil faster, right? So a perfect example, R410A is 50% for R32, 50% R125, right? Pretty easy, 50-50 mix. So if I had a leak and I lost more of the R125, I'm no longer 50-50, now I'm 52-48. I recharge it again, 54-46. Okay, that's called fractionization. So when I'm losing more of one than the other. Now, R410, the difference is really, really tiny. So 410 they determined, we can recharge 410 5, 6, 7 times without any problem of fractionization. The last I saw, I saw a thing where they did 454B, they recharge, and everybody know what I mean by that? Your system is 50% low, you don't take it out, you just add new. And out of 8 recharges, they had a 1 degree temperature difference. So yes, you can top off the charge in 454B. R32 is not a blend because it's not a 400, so that won't be a problem either. Now, that being said, when Dave talked about superheat and subcooling, you use a PT chart. Now, your fancy gauges will do this for you, but a pressure temperature chart, I think I actually have one here. Maybe I don't. I do. So, PT chart. This is where your gauges get all those temperatures from. But this is all built in your gauges. But R454B on this chart only shows a single boiling point. But of the 400 numbers actually have 2. Some charts you'll see bubble point and dew point. Again, those who remember when 410 first come out, you remember these. And what it is the difference when it begins to boil to where it finishes boiling. 410 I had about a ½ degree glide, they called it, between boiling points. So generally we only have one number. 454B's got about a 2 degree glide. So when you look on some PT charts, it will list a bubble point and a dew point. So bubble point, dew point. So depending on what I'm doing, which one do I use? So if I'm doing superheat, I use dew point. And this is the way my pea brain remembers that. Dew, think of fog, right? So coming out of the evaporator, you want fog, right? You don't want any liquid. So dew point, superheat. On the other end, subcooling is liquid, right? We have to have liquid subcool. So bubble point, you can't have bubbles without liquid. So you got to use bubble point for subcooling. Okay, and you'll probably see when you get into PT charts, some of them will have the two listed again because it does have that 2 degree glide. All right, so but that's a good point.
Yeah, but in the 410A, every unit has a subcooling tag.
Yes.
Okay, and the 454, they're gonna be something like that?
Yeah.
Or no?
Yeah, they'll be very similar. They're really close. The refrigerants are really freaking close.
We can just go with the liquid.
Between you, me, and the fence post. Damn, they're recording me. No, actually, I went to a training in Comoros, so it used to be DuPont. They took 2 410 systems in the lab. Okay, in the lab. They took the TXVs out and put EXVs in them, just 2 single speed 14 SEER condenser units. And they put 454B in them and they ran flawlessly. 410, so they put EXVs, but it was 410 compressor, condenser unit. They did it in the lab, so we can't do that. But so they are so close. Everything's going to perform. The only thing you're going to see different is the pressures are slightly less. Yeah, so for instance, 410A at 118 PSI, that sounds like a pretty normal suction pressure, 118, 120. 454B at 40 degrees is 107. So instead of 118 suction, we're going to have about 107, 108. So it's really going to be very close. But that's a good question. So, but that's also why we have to liquid charge, because we got to make sure they come out of the can in the proper mixture. But that's also why you can't mix refrigerants, because I get some guy, well, if the new stuff, so 410 was 50% R32, our 454B is 68% R32. The other 32% is 1234YF. Has anybody ever heard of that? If you've got a car newer than about 2016, it's what's in your car. So I've had guys ask me, well, why can't I put R32? Because now you've changed the mix completely. All right, so you can't mix them. If one of your helpers accidentally puts R32 into your 410A, 410A is 50% R32, so it's not dangerous, but you can't use it that way. Okay. Recovery cylinders are different because they got the red stripe on them. The new cylinders are different. They also have a red stripe on them, and they both have the backhanded threads. Left-handed threads, so you need an adapter. Your hoses haven't changed. It's only the tanks that have the backhanded thread. And their reasoning is because before you hook up to that tank, they want to make sure you know you're dealing with flammable refrigerant, so there's no mistakes. Okay.
These gauges, the analogs with 454B as the.
Yeah, they do. They do. I don't know if we have them yet. I think we do. But yeah, they're making them with the 454B on them. You use analog gauges still? Yeah. Yeah, analog gauges, again, yeah, the digitals are great. But you never learn what am I looking at? What is it? Just gives me a number. What does that mean? And you need to know what that means. And that's like I said, if you work for me 2 years, analogs, you're not touching a digital for 2 years because you have a PT chart, and you might not even get one with a refrigerant on it. You're gonna have a PT chart in your hand.
With the digital gauges, you'll never see that shaking needle that indicate.
No. No, and that being said, though, most of your digital gauges, if 454B is not on them, you can probably get them updated. So check with your manufacturer on those. I mean, they're great. Superheat and subcooling, because, when you're trying to get 10 degrees superheat and my analog gauge is off by 2 pounds, shit, it's a crapshoot. Really. But back to your question, the subcooling is going to be similar, somewhere between 8 and 12 degrees. Again, same thing, look on the tag. You got 2 or 3 degrees either way. All that is making sure you got enough extra refrigerant stored in a condenser for hotter days. So by measuring subcooling, you're measuring how much extra refrigerant is stored in a condenser. So that's all you're doing. So the only time if subcooling were a little, couple of degrees too low, if it's really low, yeah, we're really low in charge. But if so, a couple degrees, worst case on that 98 degree day, if we ever see one, you might be struggling because you just don't have, once that valve starts to modulate, you don't have enough extra refrigerant left over. Okay, anything else? All right, Now, that said, I just want to reiterate again, on the Aspen coils, if you use Aspen coils, you have to order the sensor separately. Okay, and I'm just saying that because I know myself, I'd forget. You quote a job and shit. Got this stupid thing. All right. I don't know what's so I was looking at something else when you went through this part. The stuff, like I said, the swedges are all gone. The dryer, the condenser, the evaporator, swedges are all gone. The contactor, I think, did you talk about the contactor, Al? Okay. The contactor has a solid cover over it now. There's a hole in the center so you can use your meter probe to actuate the contactor. All right. That's to keep refrigerant from accumulating around the contactor, even though a spark won't ignite it. But that's what it's for. So when you're replacing contactors, make sure you put the one back in there that it's supposed to have with that cover over it. All right. And I know you probably carry them in your truck that are the same, but they don't have the cover. That's a lot of liability by switching to that other contactor. Now, the good news is Mars, who we get our generic contactors from, they're starting to switch all the contactors to have that cover on them. Okay, so eventually that's what your generics will be too. But in the meantime, you want to replace it with that same contactor. Okay, you don't want to have that type of responsibility. Because I've even got to say, well, what happens if I don't hook up the mitigation control? That, again, you're taking on a whole lot of responsibility. Well, spark won't ignite it. It doesn't matter. If there's ever a fire in that house, you ever been involved in a fire investigation, they look at everything. We actually take a rooftop unit off of a building. They shrink wrapped it and put it on a truck to take it to the lab. It was part of a fire investigation. And the fire didn't even start in the rooftop unit. So they're going to check everything. So, well, yeah, exactly. But again, somebody said, cover your ass. I mean, you take that you put the right contactor back in, put the mitigation sensor in there. Well, maybe the board's bad. Well, I don't know about you, but I'm not going to leave that system run without it. I'm going to say, I'll be back. You're going to be without air conditioning because, again, cover your butt. The compressors, the wires to the compressor, that 3-wire plug, there's actually like a braided sheath on that now. That's just to keep it from pinching. Rooftop units have it too. Rooftop units have those contactors as well. So just, so you're not a surprise when you see them and you know why they're there. And again, don't replace it with a generic.
With the generics that have the bug covers on them, is that good enough?
No,
No.
because they still have a button where you can push the cover down. And they're not rated for A2L. The thing is, it has to be 2L rated, A2L rated. Mini split pumps, mini split condensate pumps. They're under the cover of that unit, so those are A2L rated. Okay, I guess they haven't changed them; they just got them rated. Compressors are different, so they say. Honestly, I think the compressors are probably pretty similar, but one is rated for A2L and it says A2L on it. You can't use the 410 compressor. TXV, same thing. You got a 410 TXV, you got an R454B TXV, and an R32 TXV. Down the road, I think we're going to find out they were the same. Just speculation. But if you ever did a refrigeration, 100 years ago, we used R502 for low temp, which was replaced by 404. 15 years ago, Sporlan made a 502 TXV and a 404 TXV. And then sometime later, they said, we're just kidding. They're the same, and they made them one. So they stopped making two. It's the same one for either now. So I guess that's, but in the meantime, we got to keep them separate. Okay. Anything else?
Which board, was it again that has the separate G?
Oh, that's the communicating furnace. So only the modern communicating furnace with the digital display. Okay. That is like, so it'd be 987, 986 with the digital display. And the reason they did that, what that's going to do is those furnaces, if you've ever set them up, the circulation speed can be like 300 CFM. And that's not high enough. So anything else you wouldn't use it. So if you got an older 987 without the digital display, you don't use it. If you got you might come across a 398B. Anybody remember those? Okay, so that was Bryant's first variable speed going back into the late 80s, early 90s. I actually had them in my house once, but anyways, you could even put it on those, but you don't. There's no terminal, so you just plug it into the, and it's backwards compatible. So even that old furnace, it should communicate with it. Should. Now, if you're putting air conditioning on a 398B, I think you're doing your customer a disservice at this point. You probably should say, hey, you know what? Let's change it up. So, any other questions?
I was helping a guy yesterday with it was a cover maker outdoor unit with our dispenser unit, and he had hooked up to, I don't know if it was a root or something, but when he was hooking up with, he blew a fuse at one point, and thing didn't work at another point, and we were going through wire by wire on this thing, and weirdly enough, it's critical, where they give you that red 24-volt wire that's supposed to go onto your secondary transformer wire, and you have the 24 volts red plug onto it and go in there. We found out that the furnace would work just fine, the mitigation would take out the furnace, but when we went to do it for the air conditioner, it wouldn't work. And the problem was he had the SEC1 and SET2 swapped. And so you have to have it connected to the hot side of the 24 volt.
Right. So what is the R? If you go onto your board, you got your secondary 1 and 2. This has got to go on secondary 1. So you're going to unplug the transformer, you're going to plug this in its place, and then plug the transformer on top of it. And there's another reason, as you made me think of, because if a limit trips, it shuts off all the 24 volts. If the fuse blows, it kills the entire board. This would still be powered, because the fuse is after this. So that's why they're powering this from there, because you don't want the mitigation board to be disabled just because you got a limit trip. So everybody clear on that? Yeah, but that's a good point, because when you're looking at the two secondary terminals, I think it's just a sec 1, sec 2. I think it says.
That's what we know. Yeah, that's the 1024 volts, and it's further down in the stream. So don't be tempted to just cut the terminal off and wire it into R.
I know it's on here. Yeah, I know. It's like,
Upper left hand corner?
I know it's up there. No, this one don't have one. Can't believe. Oh, there's primary. Secondary should be somewhere in the neighborhood. Yeah, I know. I said this one don't have one. Holy shit, Dave. Am I just that blind? I think they're labeled sec 1 and sec 2.
They should be. Yeah, they're right there. C1 and CC2, right by the fuse.
Right by the fuse, yeah. Well, and I know better. Yeah, so yeah, red, blue, it's labeled sec 1. So you're going to pull the wire off sec 1 under the fuse. You're going to plug this into it, and then plug the transformer in the back of it. So make sure, yeah, and that's only on the digital version of the communicating furnace. The 927 doesn't have it. The 916 doesn't have it, or 917, 916. The 927, the 927, or what? 927, every time I say 927, everybody's going to say, what's that? Because we didn't have any for a while. Okay, because it was a 926, went to 927, and we didn't have any.
I
So.
don't know if we mentioned it, but these little boxes, the way they're put together, if you try and pull up on one tab or pull up on the other, you're likely to bust that tab off rather than get the cover to come off cleanly. So if you push down with your thumbs in the middle of this thing and pull the ends up, it comes right off.
Did Brent tell you that? He did, didn't he?
I don't know.
Yes, he did. One of our TMs called me and told me, you know how to take the cover off?
Broke it though.
All right, any other questions, comments? Did you put the critiques out? Okay. All right, so last thing, there's a class review in there. We ask, that you fill those out. You don't have to put your name on them. Be honest, because we change this accordingly.